Okay, continuing in our pursuit of solving equations, we've looked at ones that are like linear and like polynomial, and now we're going to look at ones where we want to use identities, or at least look for identities to solve. So let's say that we have something like cosine alpha plus sine squared alpha equals 1. Okay, so our other tricks don't work here. We've got cosine and sine, which are unlike, and we can't put them together. We can't factor anything out. But we know that we want to be able to do something with them. So then we start thinking, well, what else can I do? Well, I could get them to be both be cosine. I can't do anything with cosine alpha, but sine squared alpha I could change. I could get them to both be cosine. So I'm going to use my Pythagorean identity here to make this 1 minus cosine squared alpha. Okay, so we know sine squared plus cosine squared is equal to 1, so sine squared is equal to 1 minus cosine squared alpha. All right, so now we've got these all in terms of cosines. We've got numbers. It looks like maybe we'll be able to do some factoring here, either common factor or trinomial factor. So let's get everything on one side and see what happens. I'm going to put the cosine alpha out first. Okay, so cosine squared alpha plus cosine alpha. The ones I can put together, so if I do minus 1, those are gone, equals 0. Okay, now if this was a trinomial, we'd want this cosine squared to be positive. We would multiply through everything by a negative. But since this is a common factor, I'm going to factor out a cosine. It doesn't really matter either way. Okay, so let me show you what I mean. If you ever have a negative in front of the cosine squared, a lot of times it's easier just to multiply through everything by a negative like this. Okay, and then that makes it easier to factor when your first one is positive. Now we didn't, like I said, we didn't need to do it for this one, but just keep that in mind. If you are trying to factor things, you want the leading coefficient to be positive typically. It makes life easier. So we can keep going from here. We can factor out a cosine alpha from both of these. I'm going to be left with cosine alpha in the first term, minus 1, because that one's gone, equals 0. So we have something times something equals 0. So we can break this up. I get cosine alpha equals 0, cosine alpha minus 1 equals 0. So cosine alpha equals 0. You can look at a graph or look at your unit circle. That's going to be at pi over 2 and 3 pi over 2. And this one, we're going to add 1 to both sides. We have cosine alpha is equal to 1, so that's going to be at 0. And then again at 2 pi, these typically solve on 0 to 2 pi like this. So it happens again at 2 pi, but the 2 pi is not included. So like if you want to, you can write down the 2 pi, but then you'd come back up here and see your interval and you'd throw that back out again. Okay, so our answers are 0, pi over 2, and 3 pi over 2 for the final answers. Okay, so look for identities that might help you as you go. All right, the other thing that you might need to do, so typically it says on 0 to 2 pi or 0 to 360, but it might also say find all solutions. Okay, so if you want to find all solutions, that means that you can't just list them out. You've got to set up a way to show all of them at once. So for example, we're going to need our ASTC, all stupid teachers cheat. So this is, remember, this is where everything is positive. So all sine, tangent, cosine. And let's say we want to solve for cosine theta equals negative 1/2. Okay, so the first thing we do is we figure out the first place that this happens. So where is cosine theta equal to negative 1/2? So not in the first quadrant because we're positive there. Second quadrant, yes. So in the first quadrant, my reference angle for 1/2, okay, this is what I'm thinking. My reference angle is pi over 3. So that's where cosine is equal to 1/2 in the first quadrant. All right, so now I want to be in the second quadrant. So pi over 3 in the second quadrant would be 2 pi over 3. And then in the third quadrant, cosine is negative again. So pi over 3 in the third quadrant would be 4 pi over 3. Okay, so we want to look and see, we want to find all of the solutions. So could I, from 2 pi over 3, could I get all of the solutions? Well, from here to here, I could add I could add pi over 3, but the problem is I can't do that repeatedly because that would hit every single quadrant. So for this solution and this solution, I can't hit all of those with one factor. So let me show you what I mean. From 2 pi over 3, I can add 2n pi. That's going to add multiples of 2 pi. So if I'm at pi over 3 and I keep adding multiples of 2 pi, that keeps bringing me around to this line. Okay, like that. So 2 pi over 3 plus 2n pi gives me all possible solutions in the second quadrant. And then 4 pi over 3 is the third quadrant solution, and we would add 2n pi to that, and that would give us all of the solutions in the fourth quadrant. So we just keep adding n pi, add n pi, add n pi, and you can even go the other way, subtract n pi, because n can be any integer. Okay, so that's the idea there, is that you take one solution and add 2n pi, and then you take your other solution in 0 to 2 pi, you take your other solution and add 2n pi. Okay, so there's a cosine one. Let's look at a sine one. So let's say we have sine alpha is equal to square root of 2 over 2. Okay, so that's positive. So we do want our first quadrant solution. Our first quadrant solution is going to be pi over 4. Okay, so we're at pi over 4 in the first quadrant. And then the other place that sine is positive is over here in the second quadrant. Okay, so second quadrant, it's going to be 3 pi over 4. So to get all of our first quadrant solutions, I'm going to add 2n pi to that. And to get all of our second quadrant solutions, I'm going to add 2n pi to that. All right, and for the most part, that's going to be, when you have cosine, you're going to add 2n pi. When you have sine, you're going to add 2n pi. I think in the next section, we might look at a couple of exceptions to that, but in general, for this section, that's how they're going to look. Okay, now tangent is a little bit different, and it may make sense that this comes into the period. So let's say that we have tangent theta is equal to square root of 3. Okay, so remember cosine has period 2n pi. So if you have a value, to keep hitting that value, you're going to have to add, keep adding 2 pi to it because that's its period. And then if you have another solution, you're going to have to keep adding 2 pi. Same thing for sine. You've got to add 2 pi to keep hitting that same exact value. Tangent, if you remember, has period pi. So let's look at what happens with this. So tangent is equal to pi over 3 when we have pi over 3 over 2 over 1 over 2. Okay, so we want sine to be square root of 3 over 2, we want cosine to be 1/2. So again, that's going to be pi over 3. Okay, so we want pi over 3. So it's positive, that's first quadrant, that's our first value. All right, so I'm like right here. Okay, but look at what happens with tangent. Tangent is positive again on the other side in the third quadrant. So what happens is you got pi over 3 here, you got pi over 3 here. So what happens is anytime you have a tangent value, you can get to the same value by adding pi to it. There's always going to be one on the opposite side. Same thing for negative. If we had a negative tangent value here, you'd have the same negative tangent value over here. Okay, so for tangent values, you don't add 2n pi, you add n pi. Okay, so if we did pi over 3 and we did 4 pi over 3 and added 2 pi, that would be, it wouldn't be wrong, but it wouldn't be the best solution. So we need to do this and add n pi to it. So when we add n pi, that's going to give us pi over 3 plus pi. That gives us the 4 pi over 3. So this is the better solution because it does it all in one. And that's what you're going to have to put that in for my math lab, or it's not going to be right. Okay, so this is what the solutions look like when you're finding all solutions for sine, cosine, and tangent. And then obviously secant, cosecant, and cotangent would be very similar.